The visible region of the spectrum is just a very small portion of the continual electromagnetic spectrum. The electromagnetic spectrum is a way in which energy moves through space in the form of electromagnetic spectrum and from one place to another. And so here we have at the top here wavelength in units of meters, and you can see the wavelength of the entire electromagnetic spectrum. What we were just looking at was a little portion of it, the rainbow part of the spectrum, which is the visible light broken down into its individual wavelengths. But going from 10 to the minus 14th to 10 to the 2, that's from very, very short wavelengths to like on the order of 100 meters from peak to peak or trough to trough. And you can see the different portions of the electromagnetic spectrum have different names. So you've got radio waves down here, the very, very long wavelengths, and you have gamma rays down here, the very, very short wavelengths. Okay, and so and then here they've broken out the visible spectrum, very small part of this whole spectrum, and they've changed the unit here to show you that the visible light ranges in wavelength from 400 nanometers to 700 nanometers. So this is all in meters up here. This is nanometers down here. So it's a tiny little segment of this broad spectrum. And remember the relationship that nu equals c over lambda. That is the frequency and the wavelength. So where the wavelength is shorter down here, the frequency is higher. All right, so now take a closer look. We know about visible, but what is to the left of visible is ultraviolet, and what is to the right is infrared. So ultraviolet is, more than the violet, and infrared is to the other side of the red. And that's how you can keep in mind which side of the visible spectrum is the ultraviolet on versus the infrared. So the infrared is at the longer wavelength range, and the ultraviolet is off the shorter wavelength range. All right, and so like the sun gives off a wide spectrum of electromagnetic spectrum, but what makes it to the Earth mostly in this spectrum is just ultraviolet light, visible light, and infrared radiation. Okay, and so this is just another snippet of that continuous electromagnetic spectrum. Now the infrared radiation, the majority of the radiation that gets to us is infrared. It's spread out over wide, long. Infrared radiation has a wider band in the electromagnetic spectrum, on the order of 700 nanometers up to 4,000 nanometers. So 53% of the radiation that gets to us from the sun is in the form of infrared radiation, and that's a good thing because infrared radiation serves to warm the Earth. That's a very good thing for us. Then 39% of all the radiation that's getting to us from the sun is in the form of visible light, and that's another good thing. Obviously we need light to see, but most importantly the visible light, the radiation, the energy from the visible region is what drives photosynthesis. Okay, that's how the energy from the sun gets into the living systems, is via the photosynthesis, where we are getting the visible energy and convert it into storage into the sugars. All right, then just 8% of the total radiation that gets to the Earth from the sun. Now let me just tell you, this radiation is all the radiation that's at the upper atmosphere. This isn't what makes it all the way down to ground level. This is looking at the radiation that makes it as far as to the top part of our atmosphere. Okay, 8% of that is ultraviolet radiation. That is a bad thing because ultraviolet radiation can damage living things.